Chapter 4, Section 4.4, Trig Functions of Any Angle. In previous concepts in this chapter, we have focused on a radius of 1. For example, our unit circle. When we made triangles on the unit circle, our radius was just 1. Well, now we're going to expand that to be a radius of any value. So now we have a new definition for our trig functions here, where r is the length of our radius. We find r by taking the square root of x squared plus y squared. You can kind of see that is derived from the Pythagorean theorem, or the distance function. So now, for example, for sine of theta, we're going to do y divided by r. That's still technically our opposite divided by our hypotenuse. We're just using this notation now. For this example, we are going to let P equal the point 1, negative 3 be a point on the terminal side of theta, and we're going to find the 6 trig functions of theta. So first of all, if you're ever not given a picture, then you need to draw a picture. So we have our terminal side, so on the x-axis we have a blue arrow, and then our angle goes all the way around from the first quadrant all the way to the fourth quadrant, and there we see our terminal side. P is on that line, and we have sides r, x, and y. We're going to start by finding r. So that's going to be the square root of 1 squared plus negative 3 squared, which gives us the square root of 10. Now I'm going to label the sides of my triangle. So I have x is 1, y is negative 3, and r is square root of 10. So sine of my angle is going to be negative 3 over square root of 10. That would be y over r, and then I need to rationalize. Cosine of theta is going to be 1 over square root 10, x over r, and then rationalize. And tangent of theta is y over x. Next, we find cosecant of theta, secant of theta, and cotangent of theta. For this next problem, we're going to start by drawing our graph. So we have P at the point 3, 7. So I'm going to go to the right 3 and up 7. And then I'm going to draw my angle. So there's my angle with theta. And then we can see our right triangle right here. Next, we need to find r. And we get square root of 58. So we can label our triangle r, x, and y. Remember, that's the point 3, 7. And now we can find our trig functions. Sine of theta is just y over r. Don't forget to rationalize. Cosine is x over r. And tangent is y over x. Cosecant of theta is going to be r over y. Secant of theta is r over x. And cotangent is x over y. Next, we're going to evaluate trig functions on quadrantal angles. So remember, that's going to be angles that lie on the axes, like 0 or pi over 2 or pi or 3 pi over 4. I'm going to again start by drawing my graph. So I'm at 0 degrees, and we don't have a value for r right now. We're going to go ahead and just let r be 1. It doesn't really matter what it is to kind of show you what I'm trying to show you here. So this point's going to be the point 1, 0. Again, we could use r equal to 50 if we want to. Let's just make it simple and use 1. So cosine of 0 is going to be x over r, so we get 1 over 1, which is 1. And cosecant of 0 is r over y, which is 1 divided by 0, which is undefined because we cannot divide by 0. And that's what we're going to be seeing here whenever we're looking at these quadrantal angles. We're going to have some of our trig functions that are undefined. For this next example, we're going to do the same thing. We're going to find cosine and cosecant, this time at pi over 2. So I have my angle drawn. Again, I'm just going to let r equal 1. So that point is 0, 1. So cosine of pi over 2, we're going to just get 0. And cosecant, we get 1. So both of these trig functions are defined at pi over 2. For the next example, we're going to use 180, or pi, which I have drawn here. Again, we're going to let r equal 1. So cosine of pi, we get -1. And cosecant, we're going to have a divide by 0 again, which means it's undefined. And again at 3 pi over 2. So I have my 3 pi over 2 angle drawn here. We're going to let r be 1 again. Cosine, which is x over r, we will get 0. And cosecant, which is r over y, we're going to get -1. So the point here with these problems is that sometimes our trig functions are not defined on quadrantal angles, depending on whether or not we're dividing by 0. We're going to look at the signs of trig functions. So depending on the quadrant that your point P falls in, will determine if your cosine function is positive or negative, or if your sine function or any of the other ones, what their sign is. So here's a way to remember this. So quadrant 1, all the functions are positive. Quadrant 2, only sine and cosecant are positive. Quadrant 3, tangent and cotangent are positive. And quadrant 4, cosine and secant are positive. So here's a little mnemonic to help you remember. We've got all students take charge. So the way we can look at this is in the first quadrant, all the functions are positive. In the second quadrant, only sine, and we just have to remember that cosecant goes with sine. So sine students both start with S. In quadrant 3, tangent starts with a T, take. And quadrant 4, cosine, charge. So as long as you remember that tangent and cotangent go together and cosine and secant go together, this little saying of all students take charge should help you remember which functions are positive in each of the quadrants. Find the quadrant in which the angle lies. If sine of theta is less than 0, which means that sine is negative, and cosine of theta is also less than 0, which means cosine is negative, then name the quadrant which the angle lies. So it's definitely not quadrant 1 because everything's positive there. It can't be quadrant 2 because sine is positive there. And it can't be quadrant 3 because cosine is positive there. So we know that angle theta lies in quadrant 3. Evaluating trig functions. Given that tangent of theta is equal to -1/3 and cosine of theta is negative, less than 0, find sine of theta and secant of theta. First of all, we need to determine which quadrant theta is in. Cosine of theta is negative, so we have to either be in quadrant 2 or 3. Tangent of theta is negative as well, so this means that we're in quadrant 2. Next, we're going to use the definition of tangent to figure out what our x and our y values are. Since tangent is equal to y over x, I know that we can write it as 1 over -3. The reason I'm giving the negative down to the 3 and not to the 1 is because we're in quadrant 2. In quadrant 2, our y values are positive, but our x values are negative. So we have tangent of theta equals 1 over negative 3, which means that x is equal to negative 3 and y is equal to positive 1. Next, we need to find our r value, our radius. We're going to plug negative 3 in for x and 1 in for y, and when we evaluate this equation, we get square root of 10. Now that we have our radius, we know that sine of theta is equal to y over r, so that's just going to be 1 over square root 10, and then we need to rationalize. So we get square root 10 over 10. Then to find secant of theta, we know that secant is r over x, so we get square root of 10 over negative 3, which gives us negative square root 10 over 3.